All right, so inverse functions. Let's just take a moment to remember what we know about inverse functions. What do we remember about inverse functions? We did them way back in chapter 1. We talked about them again in chapter 3. Chris? Okay, we switch out x and y. So if we have y, if we have y equals sine of x, then the inverse would be x equals sine of y. Okay, so the inverse would be x equals sine of y. Okay, we typically like to solve for y. Yes? Yes, yes. So y equals sine inverse of x is how we write it. Okay, you guys have all seen those buttons on your calculator. Yes, a function and its inverse will undo each other. And we'll talk about it more specifically because in this case we have to be very careful about the domain and range of both of these functions. Okay? Let's talk about the sine function first. Okay? Graphically, I think red is a better choice here. Graphically, this is what the sine function looks like. And you don't need to draw this yet. Do you remember graphically what happens with our inverse functions? There's some sort of reflection over y equals x. If we were to graph this as a reflection over y equals x, this would happen. Is that a function? It is not a function. So in order to make it a function, we restrict the domain. And actually, the domain would not be restricted, the range would be restricted in this case. Okay? What we're going to do is we're going to take that and we're going to restrict it to where we're only between negative pi over 2 and pi over 2. Okay? So this is what I want you to write down. You don't have to write down the graph, but it may be a nice visual for you. I'm not going to make you graph these. But this is the graph of the inverse sine. First thing I need you to understand is there's two notations for the inverse sine. You're familiar with this notation, but arc sine is also the same thing. I'll tell you right now, you're going to see both. So you need to understand that those mean the same thing, and it's just the inverse sine. Okay. What is the range of the sine function? And in our parent function, what would that be? Negative 1 to 1. So the domain of the inverse is negative 1 to 1. You remember our domain and ranges. Switch. Okay. Now, in order for this to be a function, yes, I know the sine function has a domain of all real numbers. We cannot have a range of all real numbers. Instead, the arc sine function or the inverse sine function has a range of negative pi over 2 to pi over 2. Okay. The output for an inverse trig function is an angle, right? For a regular trig function, we're inputting an angle. Inverse trig function, our output is an angle. Now, I understand that there are an infinite number of times that the sine function is radical 2 over 2 on the unit circle. However, if I ask you for the arc sine of radical 2 over 2, you can only pick a value between negative pi over 2 and pi over 2. Okay? Well, what does that mean? That means on the unit circle, we are restricting ourselves. Negative pi over 2 is here, pi over 2 is here. Quadrant 1 and quadrant 4 are the two quadrants that our outputs will be coming from. But quadrant 4, those are going to be negative angles. Negative pi over 2, negative pi over 3, negative pi over 6, etc. That doesn't work at all. Okay? So like I said, if I asked you for the arc sine of radical 2 over 2, well, we would say that is pi over 4. Because pi over 4 is in the range, negative pi over 2 to pi over 2. If I asked you for the arc sine of negative radical 2 over 2, what would you have to tell me? Almost. It does have to come from quadrant 4, but it has to be between negative pi over 2 and pi over 2. So instead of 7 pi over 4, you have to tell me negative pi over 4. Do you see what I mean there? Okay. So it's actually kind of nice, because it's either positive in the first quadrant or negative angles down here, right? We don't really have to think about the 7 pi over 4. What is that? All right, let's do the same thing with cosine and then eventually tangent. All right? The cosine function, looks like this. Domain, all real numbers, range, negative 1 to 1. Okay? If we reflect it about y equals x to get the inverse, we get something that looks like that. Not okay, right? It's not a function. So what we have to do, we have to restrict it. If we follow the same method that we used in inverse sine, negative pi over 2 to pi over 2 would be this chunk right here. Is that a function? That is not a function. So we have to restrict it in a different way. Our inverse cosine function is restricted like this. Okay? This piece is a function. All right? So what ends up happening is that our inverse cosine has a domain of negative 1 to 1, just like the inverse sine, but a range of 0 to pi. The domain of the range of cosine is negative 1 to 1. So the inverse cosine has a domain of negative 1 to 1. We have to restrict the range so that we have a function. And for inverse cosine, that turns out to be 0 to pi. Okay? So that means when we're thinking about the unit circle, we're thinking about angles in which two quadrants? We're talking about angles in quadrant 1 and 2. Positive angles in quadrant 1, negative cosine values, but still positive angles in quadrant 2. For example, if I asked you for the inverse cosine of 1/2, you would tell me what angle? Where's the cosine 1/2? Okay, so pi over 3. However, if I asked you for the arc cosine, inverse cosine of negative 1/2, we would have to go to the second quadrant and choose the angle 2 pi over 3. No. For arc cosine, we rotate positively to quadrant 1 and quadrant 2. Because the range of arc cosine is 0 to pi. So those are the values our outputs have to be between 0 and pi. Okay, last but not least, let's recall what the tangent function looks like. Okay, that's our tangent function, right? If we decide to reflect about y equals x, this is what's going to happen. That's going to happen over and over and over. Is that a function? No. So what happens very similarly to arc sine is we are going to restrict the range here to look like this. This is the graph of arctangent. Notation still is the same. Our inverse functions, we either call them arctangent of x or tangent with that -1 symbol, the inverse tangent of x. Okay. Question, what's the range of our tangent function? All real numbers, which means the domain of our inverse tangent is all reals. That's nice. We can plug anything into the inverse tangent function. Okay, and almost exactly like the inverse sine function, our range is the interval of -pi/2 to pi/2, but do notice that it's the open interval where the inverse sine was the closed interval. That's because we have asymptotes at pi/2 and -pi/2 for tangent, so it has to be the open interval. Okay, so if we're thinking about the unit circle, just like in inverse sine, we are grabbing our outputs, positive angles in the first quadrant, negative angles in the fourth quadrant. And when I say negative angles, I'm talking about the angle measure is negative. Yes, the tangent ratio is going to be negative, but our angle measures will too. Okay? What do I mean by that? I mean, it's just like arc sine. Okay? If I ask you for the arc tangent of 1, which angle does that occur at? What? Okay. So we're going to stick in radians, pi over 4. Now, yes, I know the tangent ratio is 1 at pi over 4, and 5 pi over 4, and 9 pi over 4, and I can keep going and going and going and going, right? But when we're talking about arctangent, I only want from the first quadrant, okay? Because the range is negative pi over 2 to pi over 2. If I ask you for the arctangent of negative 1, which angle would you have to tell me? Negative pi over 4. Okay? We know that between the first and fourth quadrant, tangent's negative in the fourth quadrant. So we have to call it negative pi over 4 so it fits in this range. Okay? So what you need to remember is which outputs you need to pick from. Okay? Inverse sine and inverse tangent have the same outputs, negative pi over 2 to pi over 2. Cosine has outputs from 0 to pi. That's what you're going to have to keep straight. Okay? So let's do some examples here. Go ahead and write these two down. We have the arcsine of negative 1/2 and the inverse cosine of negative radical 3 over 2. Okay, and arcsine of negative 1/2. First of all, where is the sine ratio 1/2? Pi over 6. Since it's negative 1/2, we have to call the angle negative pi over 6. Inverse cosine of negative radical 3 over 2. Where's the cosine radical 3 over 2? Ooh, pi over 6. Now, we have negative radical 3 over 2 and its inverse cosine. Which quadrant do we need to go to? We need to go to the second quadrant. So 5 pi over 6. Third example, inverse sine of 2. Inverse sine of 2. Go back and look. What is the domain of inverse sine? Negative 1 to 1 is 2 between negative 1 and 1. No, this is undefined because 2 is not in the domain. Go ahead and try it in your calculators. Press inverse sine of 2. What happens? What happens when you press the inverse sine of 2? It literally should say domain error, right? Or error domain, okay? That's why. Okay. Don't worry about this third one yet. Go ahead and write these two examples down. The arc cosine of radical 2 over 2. That's asking you, where is cosine radical 2 over 2? What would you say? Pi over 4. That's a nice one, isn't it? Okay. Inverse cosine of negative 1. Where is the cosine negative 1? Pi. Does that fit in the range of cosine, inverse cosine? Inverse cosine's range is 0 to pi, so pi is an acceptable answer. Okay, last one on this page. Inverse tangent of negative radical 3. Let's first of all let's not worry about the negative yet. When is the tangent ratio radical 3? Pi over 3. So if I'm saying the inverse tangent of negative radical 3, our answer would be negative pi over 3. Okay? Inverse sine and inverse tangent are nice because it's either positive acute angle or negative acute angle. Okay? We don't have to think about what that fraction would be. Okay? With your calculators very quickly, we're going to do one example because I feel like you know how to use your calculators, especially if you did the homework last night. But if you see the arctangent of negative 8.45, now it does say in radians, so change your mode to radians. And then I want to know the arctangent of negative 8.45. What do we get?
Negative 1.45.
Okay. What I really need you to keep in mind is that the input to an inverse trig function is some sort of ratio. Sometimes it looks like a fraction, sometimes it looks like a decimal. The output is an angle. Okay. All right. We are going to talk about some properties, okay? They're going to make a lot more sense when we do some examples. So write them down and we'll talk through them, but I promise you when we do examples, it will feel better, okay? So, if x is between negative 1 and 1, and y is between negative pi over 2 and pi over 2. That looks like the domain and range of inverse sine. So if x fits in the domain, y fits in the range, then our sine and inverse sine functions can undo each other. If our ratio is between negative 1 and 1, our angle is between negative pi over 2 and pi over 2, then our inverse functions can cancel out like you were mentioning earlier, Caleb. If these do not fit, then we either have to take one step at a time or it's just not going to work at all. And I'll show you what that would look like. Same thing for our inverse cosine and cosine functions, except we have to have x between, well, x was between negative 1 and 1, but now our angle needs to be between 0 and pi for them to be able to cancel out and undo each other. If our ratio is between negative 1 and 1, and our angle is between 0 and pi, then cosine and inverse cosine can cancel each other out. Okay? And then I bet some of you could even start writing the property for tangent inverse tangent. Okay? X can be any number because our domain is all real numbers. Y between negative pi over 2 and pi over 2. That's the range for arctangent. Then tangent and arctangent can cancel each other out. Yes.
So for tangent, it's not inclusive after the y value.
Correct, because we have asymptotes at negative pi over 2 and pi over 2, so we can't include them. Okay? All right, we have 5 examples, and then I have an exit ticket for you. Okay, so we're almost there. And these examples go really quick. First one, the tangent of arctangent of negative 5. When we have unit circle values, these problems are more straightforward. When we have values that we don't have memorized from the unit circle, then we have to think outside the box a little bit. Now, since this is an input for arctangent, it's a ratio. What needs to be true about the ratio for arctangent in order for these to be able to cancel each other out? X could be what? Could be anything, right? All real numbers. So, since this is a real number, tangent and arctangent can cancel each other out, and we have negative 5. Okay. When you have the tangent of arctangent, that'll happen every time because the domain is all real numbers. Okay. We're not so lucky in other times. Okay. Like this. The arc sine of 5 pi over 3. Okay. Please do not write this down. Okay? You are going to be tempted to be like, sweet, these cancel and it's 5 pi over 3. Is 5 pi over 3 an acceptable answer if your problem is arc sine? It is not, okay? We cannot do that. 5 pi over 3 is not in the range of arc sine. So what we have to do is we have to go one step at a time. The arc sine of, what is the sine of 5 pi over 3? Negative radical 3 over 2. Now we can say, okay, the arc sine of negative radical 3 over 2 is negative pi over 3. We know that the sine is radical 3 over 2 at pi over 3. And since it's negative, we have to rotate negatively to the fourth quadrant for our answer. Cosine of inverse cosine of 3. Okay? Some of you are going to be tempted. Ooh, cosine inverse cosine. Those cancel and it equals 3. But you have to think about your answer. Can we have a cosine value that equals 3? Okay? Or even this. If you go one step at a time, can we take the inverse cosine of 3? No, it's not between negative 1 and 1. You could even try it in your calculator. There's a domain error. So we have to say that this is undefined. The tangent of arc cosine of 2/3. Is 2/3 a unit circle value? It's not, which means we have to draw a picture. Not a problem. We can draw pictures. Arc cosine is describing an angle, and since it's positive, it's describing a first quadrant angle, where the cosine is 2/3, adjacent over hypotenuse. What's our missing side? So arc cosine of 2/3 is describing this angle right here. And the tangent of that angle would then be radical 5/2. So it's kind of taking like that question from our very first quiz, the tangent is this and the cosine is this. Figure out what the answer is. Like squishing them all into just one mathematical sentence. Questions about that before our last example? Our last example is another one of those. Okay. Cosine of arc sine of -3/5. The arc sine of -3/5 is describing an angle where? Since it's arc sine, it needs to be in the fourth quadrant. And our sine ratio is -3/5. What would this adjacent side right here be? Okay. So now we're looking at the cosine of that angle, adjacent over hypotenuse 4/5. Okay. Now, I believe from talking with your Algebra 2 teachers, this isn't the first time you've seen inverse trig functions, is that correct? Okay. But it's still a lot to wrap your head around. You have to keep track of the domain and range of each of the functions in order to be able to answer the questions, okay? So before you leave today, I want to make sure you at least have the basic types of problems under control. So as a pod, we only have 4 minutes to do this, but I think you can handle it. As a pod, come up with some answers and I can come around and check before you leave. Homework is on the gold sheet.